Welcome back, everybody, to another deep dive. This time, we're taking a look at auto-scaling groups of instances on Google Cloud.
Yeah.
This stuff is really cool, and we'll see why in a second, but just to set the stage,
Yeah.
um, imagine your cloud resources. They kind of expand and contract just like breathing, in response to demand. And that's basically auto-scaling.
Yeah, and what I really like about it is it takes all the headache out of scaling manually. It really helps you to use resources more efficiently and at the end of the day, you're going to save money. But there's so much more to it than just adding more virtual machines, when things get a little busy.
Okay, so let's dive into that then. Our source today is straight from Google themselves. It's their documentation called Auto-Scaling Groups of Instances. And the document itself, goes deep into this concept, but we're going to, pull out the good stuff for you guys. Now, one of the things they talk about is this idea of a managed instance group, or MIG for short. What exactly is that?
So you can kind of think of a MIG as like a blueprint for your VMs, your virtual machines. It's a collection of virtual machines that are created from the same template. And one thing that's important to remember is autoscaling only works with these managed instance groups.
Oh, so you're saying if I've got a bunch of VMs just doing their own thing, auto-scaling can't touch them.
Yeah, that's right. They've got to be part of a MIG to, for that autoscaling magic to happen.
Gotcha. Okay, so we've got our MIGs. They're all ready to scale. But how does the system know when to actually add or remove these VMs from the group?
Well, that's where the autoscaling policy comes in. You can think of this policy as like the brain of the whole operation. And basically uses different signals to determine when it's time to, either scale up or scale down.
Okay, and I see the documentation mentions CPU utilization as one of those signals. Is that basically just checking if the VMs are working too hard?
Yeah, that's a good way to put it. So, CPU utilization is kind of like taking the temperature of your VMs. If they're consistently running hot, it's a good sign they need more help. So the autoscaling policy, springs into action and adds more instances to the MIG, and that helps to spread out the load.
Okay, that makes sense. But what about applications that aren't really CPU bound? Like what if the bottleneck is somewhere else?
Well, that's really where the power of autoscaling comes in. Google Cloud lets you go beyond just looking at CPU. You can actually scale based on a bunch of different signals, like HTTP load balancing serving capacity, or even custom metrics that you've set up in cloud monitoring.
Okay, so I could look at like database response times, for example. If my app uses a database heavily, then I could tell the auto-scaling policy to, scale up if the database gets slow.
Yeah, exactly. You're not limited to just looking at, how hard the VMs themselves are working. You can really fine-tune your scaling based on, the needs of your specific application. And that level of customization is what makes auto-scaling so powerful.
Wow, this could be a serious game changer, especially for apps that have, unpredictable traffic. But the document also mentions something called schedules. What's their role in all of this?
So, schedules are a really useful way to handle those predictable traffic spikes. Like, let's say you run an e-commerce site and you're going to get a ton of traffic every weekend. You can set up a schedule that'll automatically scale up your instance group on Friday, just to be ready for all those shoppers hitting your site. And then when things calm down, maybe on Monday morning, it'll scale back down to save resources.
Oh, that's brilliant. So instead of reacting to changes after they happen, you're getting ahead of it. It's like you have a crystal ball for your cloud resources.
Speaking of crystal balls, there's also something called predictive auto-scaling. And this is where it gets really interesting. It actually uses historical data to, try to predict future load. And it scales up before that surge even hits.
Hold on, it can predict the future. I got to hear more about this.
Well, it's not magic or anything. It leverages data analysis and machine learning. So basically, Google Cloud will look at your past usage patterns and try to find trends, like, are there busy times, are there slow times, and so on. And then it uses that information to predict when you might need more resources. And then it scales up your instance group in anticipation.
So like if my app always sees a huge spike in traffic on Tuesday afternoons, predictive auto-scaling would learn that and just scale up automatically?
Yep, that's the idea. This is really valuable for applications that take a while to start up, because it makes sure that those new VMs are fully up and running and ready to go when that traffic comes in.
Okay, this is really cool. So we've got our MIGs, they're ready to go. We've got a policy that reacts in real time and can even predict future needs. But I'm guessing it's not all perfect. What about when demand drops? How does it know when to scale back down, and how do we make sure it doesn't do it too quickly?
That's a really important question. Scaling down gracefully is just as important as scaling up. And that's where scale-in controls come in. These are like safeguards that prevent the autoscaler from overreacting to like small dips in traffic.
Okay, so what's stopping it from shutting everything down? The moment things slow down a bit.
Well, there are two key parameters that the documentation talks about for these scaling controls. One is the maximum allowed reduction, and the other is the trailing time window. The maximum allowed reduction basically limits how many VMs can be removed at a time. And then the trailing time window is like how far back in time the autoscaler is looking when making its decisions.
Oh, so it's not just looking at this very second, it's looking at the overall trend. So it can make sure the app has enough resources even if there's a small dip.
Exactly. It's about finding the right balance.
This all makes a lot of sense. So we've covered how autoscaling works, the MIGs, setting up policies, handling real-time demand, predicted demand, and even making sure it scales down gracefully. Did I miss anything important?
I think you got it. You've really captured the core of autoscaling there. But now let's dive a bit deeper and see how we can use this in the real world. So earlier, we were talking about how you can use any cloud monitoring metric as a signal for your autoscaling policy. And this is really cool because
Hmm.
it gives you so much control over, when and how you scale.
Yeah, it sounds amazing, but I gotta admit I'm having a little trouble picturing how I'd use that in practice. Like,
Mhm.
I get scaling based on CPU, but
Mhm.
what are some other metrics I might want to use? And how would I even know which ones are the right ones to pick?
Yeah, it's a great question. It really comes down to, what your application actually does
Hmm.
and where those performance bottlenecks might be. So for example, let's say you have an application that relies on message queues.
Okay, like a system that processes tasks and puts them in a queue for workers to pick up.
Exactly.
But,
Now, in this case, just looking at CPU might not be enough. Like, what if your CPUs are just sitting there idle, but the queue is growing super fast because the workers can't keep up? That's a clear sign you need to scale, but just CPU wouldn't tell you that.
oh, I see. So I could set up a metric to track how long that queue is
Yeah.
and tell the auto-scaling policy to scale up when the queue gets too long.
Exactly. So you're scaling based on what's actually happening in your system, not just a general measure like CPU.
This opens up a lot of possibilities. It could really help to fine-tune performance and, make sure we're using resources efficiently.
And it can save you from, those late night troubleshooting sessions when your application suddenly hits a wall.
So we've talked about reactive scaling, where the system responds, as things change. And we talked about schedules, which are good for those planned events. But what about this predictive auto-scaling? That still feels a little like magic to me. Like, how does it actually learn from that historical data?
It's all thanks to these machine learning algorithms that analyze your past usage. They're basically looking for patterns in your application's demand, like when are things busy, when are things slow.
Is it kind of like those streaming services that recommend shows based on what you've watched before, but instead of suggesting movies, it's suggesting how many VMs I might need?
That's a great analogy. It's all about recognizing patterns and then making predictions about the future based on that.
Okay, but what if my app's traffic is just kind of all over the place? Will predictive auto-scaling still work?
It works best when there are some clear patterns, but even if things are a bit unpredictable, it can still be really helpful. Think of it as a safety net. Even if it doesn't predict every spike perfectly, it'll still react much faster than a purely reactive system.
I see. Like it gives you a head start. Especially important if you have an application that just can't afford any downtime.
Yeah.
But even with predictive scaling, there's still going to be some delay between, the system realizing it needs to scale up and those new VMs actually being ready to go.
That's right. You've got to remember that initialization period we talked about earlier. It takes time for those VMs to boot up, load the software, and get everything ready.
Right, of course. So how does the autoscaler handle that time? When traffic might be going up, but those new VMs aren't ready yet.
Well, that's where the stabilization period comes in. It's designed to prevent the system from just constantly adding and removing VMs. In response to every little change in load, it's like a shock absorber for your infrastructure.
Okay, I like that analogy. Tell me more about how this shock absorber works.
So during this stabilization period, the autoscaler takes a step back. It's not making any rash decisions. It looks at the overall trend and focuses on the peak load over a certain time period. So it only scales if it sees sustained changes and
Oh.
ignores those small blips that might otherwise cause it to overreact.
So it's like a thermostat. Doesn't turn the heat on and off constantly. It waits for a real change in temperature.
Exactly. And just like a thermostat keeps your room at a comfortable temperature, the stabilization period makes sure your scaling is nice and smooth. It prevents those big swings in the number of VMs, which can cause performance problems or cost you more money.
Okay, so we've covered scaling up, reacting to those real-time metrics, predicting future needs, all that good stuff. But what about scaling down? Seems like that could be just as tricky, especially if your apps take their sweet time to shut down cleanly.
Yeah, you're right. If you scale down too quickly, you can run into trouble. Disruptions, even data loss, it's not pretty. That's why the Google Cloud documentation puts so much emphasis on these scale and controls.
We touched on that a little earlier, but could you remind me how those actually work? Like, what are those key things that make sure downscaling goes smoothly?
Sure. So we've got two main parameters here, the maximum allowed reduction and the trailing time window. Maximum allowed reduction, that's pretty much what it sounds like. It sets a limit on how many VMs can be removed within a certain time frame.
Okay, so it's putting the brakes on how fast the instance group can shrink,
Yeah.
but how do we figure out that time frame?
That's where the trailing time window comes in. It's like this window of time that the autoscaler looks back on. It sees the peak load over that window. And even if traffic dips a little, it won't scale down too much. That way it's ready if traffic suddenly jumps back up.
So it's not just about what's happening right this second. It's taking those recent demand patterns into account, make sure the system doesn't scale down too early and then get slammed if things pick up again.
Exactly. It's all about finding the right balance between keeping costs down and keeping things running smoothly.
Gotcha. So is there like a magic formula for figuring out the best values for these parameters, or does it totally depend on the application and its traffic?
Yeah, it really depends on your specific application. If you've got an application that can handle a bit of latency and cost is a big concern, you might go for a more aggressive scale-in setup, shorter trailing time window, higher maximum allowed reduction.
So you're willing to trade a bit of speed for lower costs in that case.
Exactly. But if you've got a critical application, one where even a tiny hiccup is a big deal, then you'd want to be much more careful. Longer trailing time window, lower maximum allowed reduction. Got to make sure there's always enough capacity, just in case.
Makes sense. It's all about knowing the trade-offs and finding what works best for you.
Absolutely. And remember, you can always tweak those parameters later as you see how your application behaves under different loads.
Now, before we wrap this up, there are a couple more things from the documentation I wanted to mention. First, auto-scaling versus auto-healing. Can you quickly clear up the difference?
Sure, it's easy to mix them up. They both sound similar, but they do different things. Auto-scaling is all about adjusting the number of VMs, matching it to the demand. Auto-healing, on the other hand, is about keeping those individual VMs healthy.
So auto-scaling is about capacity. Auto-healing is about resilience.
That's a great way to put it. Auto-healing will automatically replace any VMs that aren't doing well. That keeps your app running smoothly. It's like having a mechanic who's always watching your fleet of vehicles and swaps out any that break down.
I like that analogy. Okay, and one more thing that caught my eye. The documentation says auto-scaling is free. You only pay for the actual compute resources you use, not for the auto-scaling service itself.
That's right. Google Cloud doesn't charge you extra for using autoscaling. It's baked right into the platform. It's there to help you keep your costs down. But you still need to keep an eye on things, set those limits so you don't get any nasty surprises on your bill.
Good point. It's easy to think auto-scaling will magically solve everything, but you still need to use it carefully.
Absolutely. Like any powerful tool, you got to use it responsibly.
Well, this has been a really great deep dive. We learned about the basics of auto-scaling and even got into some of the finer details. I feel like I've got a much better grasp on how it works now and all the benefits it can bring.
I'm glad to hear it. Autoscaling is a really cool technology, and it's only going to get more important as we move towards a more automated world.
For sure. It's exciting to think about where it'll go from here. To our listeners, we encourage you to check out that Google Cloud documentation and maybe even play around with auto-scaling yourselves. You might be surprised how much easier it can make your life and how much it can boost your application's performance and efficiency. Until next time, happy scaling, everybody.